The purpose of this video is to go through the kind of the nuts and bolts of what a formal lab report looks like in Chem 105. And we're going to be focusing today primarily on the empirical formula lab report and how to focus mainly on the writing of that report. So if you're looking for more detailed explanation for how to do the error analysis, that's a separate video that I'll link in the description here. But for today, what we are focusing on is we are focusing on the lab report itself. And so if you go in here to lab archives, you will see that here in lab archives, we have this information all tucked away in this page on the information on the formal lab report right here. And so what you'll find is this document here, the writing guide and the rubric. And you'll also find a sample lab report and the kind of nuts and bolts of the quantitative error analysis, at least in terms of what are the tolerance values for the given instruments. Like I said, in the description, there's going to be a link to another video that will go through how to do this and will give you an example of what it looks like to do that. But that's a different topic. So one important note here about the sample lab report, this is intended as a guide. This lab report does address most of the big ideas that are found here in this rubric, but it does not address all of them, or at least not all as well as we might like. So do kind of take it with a little bit of caution, and also understand that although the procedure here and the theory are good, they are not your intellectual property. They belong to somebody else. And so anyone who copies or, severely borrows from the material in that sample is likely guilty of plagiarism and would have to be dealt with accordingly. So just kind of keep that in mind. Use it as an idea, as a framework, as a guide, but don't start ripping off the material from it, because that will be pretty easy to figure out. And the consequences are pretty severe for plagiarism. So we just want to avoid it in general. So onto the rubric and guide here. So what you'll see is that as far as the formal lab report is concerned, there are 10 primary areas that we are looking at. And they range from relatively simple things like just, does it have a title? Are there headings? To real complicated stuff like error analysis and incorporating conclusions and things. So what you want to do, what you want to know here is really this. You want to know what to do in each of these sections. And so let's start here at the top. Title and headings. So our expectation is that your report is going to have a cover page. On that cover page, it is going to have the title of the report, along with your name, when you did the experiment. Along with the title page, we are going to expect that each of these subsections has a proper heading or appropriate subheadings. Some good kind of ways to see that structure. If you go to the formal lab report, this is not a formal title page. This is kind of just a heading. We would want that on a separate document, but you can see here I've got a title. Not only is it a title, and one thing that we really want to focus on and caution you over is don't just rip off the title of the lab that we put in lab archives. That's not nearly specific enough. But doing something simple like this, determining the empirical formula of a copper sulfur compound, we've at least given a little bit of specific kind of nature to this, where we know, okay, we're trying to figure out what this is, and more specifically, we know that the compound is made out of copper and sulfur, as opposed to just being made out of anything. And we can see the structure here as well. Here I've got a heading, scientific purpose, theory and background. Under those headings, I can have subheadings. So here's the procedure heading. I've divided the procedure into sub pieces. the preparation phase where we washed everything and collected all of our stuff, the reaction phase where we heated it up on the Bunsen burner, and then what we saw in observations. So this is a perfectly good structure and headings, and the headings help us to organize the space so that it's not just one long continuous essay, but rather broken up in appropriate ways. Now for the purpose statement. The purpose statement, we are looking for an accurate but concise series of sentences that describe what the purpose of the experiment was. And there's a number of different ways that we can kind of look at it. But what we want to make sure is we want to make sure that, first of all, we're using complete sentences, we're using paragraph formatting. So it's not just a list of bullets. It's not just a list of items. Where you have to be really careful here, it's very tempting to go to the notebook and in the introduction and find those objectives and say, okay, these were the purposes of the lab. That's not the case. These might be instructional objectives, things that we should be able to do by the end of the experiment, but they are not necessarily the purpose of the experiment. The purpose of the experiment isn't to write equations. The purpose of the experiment isn't to calculate percent error. The purpose of the experiment was to make the compound and figure out what it is. And so that needs to be reflected in this section. And so along with the why question, there's also a what question that's kind of implicit here. What were you doing? What was the technique you were using as you did this data collection, your N analysis? So, what was the driving kind of factor there? What were you learning as far as a technique was concerned? What were you using? Section 3 here is probably the most difficult section to write for most of you. And it's because you don't know necessarily what to write. And so from theoretical standpoint, what we're looking at are what are the key concepts that drove this lab and pushed you in the direction of doing the lab this way. So again, paragraph format, complete sentences. What we're looking for are, what are the chemical concepts? So in this case, we're looking at, the fundamental laws, law of conservation of matter, law of definite proportions, law of multiple proportions. You're going to want to define each of those. You're also going to want to preliminarily interpret those in terms of what the expectations would be for the reaction that you did. So for like law of conservation of mass, we made a pretty big assumption that the amount of copper that we started the reaction with was the same as the amount of copper that we ended the reaction with. Now we can do that because of the law of conservation of mass. It says mass is neither created nor destroyed. But we have to state that. We can't just assume it. And so this is the place where we would state that. So in addition to that, this would also be the place where we would introduce any other kind of technique-oriented stuff. So, why did we use analytical balances instead of centigram balances? What was the purpose there? Why go through that extra mania to do it? How did any of the stuff that we did impact the way that we collected our data, interpreted our data, analyzed our data? Section 4, procedures. This should be pretty easy to write. You've been given a procedure in the lab manual. Now, where we want to make sure that you understand is this cannot be just a set of instructions. The purpose of a procedure section is not a list of instructions. It's not a point by point, I did this, then I did that, then I did that, then I did that. What we want to know is, what was the process that you went through to create this compound and analyze it? Now, a couple of things about that. First of all, this is scientific writing, so we have to abide by a couple of stylistic choices. First of all, past tense. We're talking about something that happened before. So we want to make sure that we phrase that properly. This isn't something that was done, or this isn't something that will be done, or you're not instructing someone to do this thing. You're talking about something that you did in the past. And so it should read like that. Again, it's not a set of instructions. It shouldn't read like an instructional manual. It shouldn't read like a list of steps. It should read like kind of like a story in some ways. Paragraphs describing what was done, what was observed, what happened as you went through each of these things. But in addition to being past tense, it also needs to be passive voice. And what that means primarily is no personal pronouns. It is not I did this, I did that, or we did this, we did that, or even the student did this, the student did that. We want to talk about things from a very objective kind of point of view. And that's where passive voice, can be really difficult, is trying to maintain that objectivity while at the same time being interesting and having good writing style. So instead of saying I took the crucible and weighed it on the balance, you just remove yourself from that. The crucible was weighed on the balance. Instead of saying I turned on the Bunsen burner and heated the crucible for 15 minutes, you say the crucible was heated over a Bunsen burner for 15 minutes. All that you're doing, you're still staying in past tense, but you're removing that personal aspect out of it. And that's what passive voice is all about. You're just removing yourself from the equation. You're talking about the things from almost like a third party kind of perspective. For the observations section, what we're looking for are physical descriptions of the reactants and the products, and for a description of what happened as the reactants went to products. So in your lab notebook, your observations on the data analysis section, that should help a lot. All you need to do is turn those observations into sentences, and that would satisfy this section. Chemical equations. In this experiment, you observed two different chemical equations. You observed the reaction between the copper and the sulfur to make whatever it was that was your empirical formula. And you observed the excess sulfur burning in oxygen to create sulfur dioxide. You need to have both of those equations present, and you need to have both of them balanced, or you will not get full credit. In section 7, we're talking about the data table. You have access to a pretty good data table based on what you made in the experiment. All that you need to do is just figure out a way to copy and paste that from lab archives into your report, and it should work pretty well without very much formatting. Just make sure that it looks good, it looks professional, and that you've got all the required components. All of the measurements have the proper precision, they all have units, they're all organized and professional looking. Similarly, calculations. We want a professional presentation of the calculations that were done and the proper use of significant figures. At minimum, what you need to have are a series of sample calculations. So take trial 1, for example, go step by step through trial 1, show how you got each of the numbers, and then you can present the rest as a table of sorts and just kind of show all of that out. Making sure that each calculation has a sample calculation associated with it. All of your calculations, all of your numbers are shown somewhere, and that they're all rounded properly and have proper units. the last two sections kind of go together, error analysis and conclusions. So conclusions kind of we use as just a summary board. We're going to kind of take everything that was in the previous 9 sections, put it into a compact paragraph or two, and just kind of put everything together. Did we meet the purposes of the experiment? What were the final results? What was the error? Did we, we tested the law of definite proportions in this experiment. We did so by manipulating how much sulfur was in the second trial. Did that do anything? Did it create a new compound of copper and sulfur, or did we get the same compound of copper and sulfur? Well, if we got the same compound, that's a confirmation of the law of definite proportions. We need to state that. We need to state why that's important. For error analysis, again, I'll give you a more detailed video on that in another video. But what we're looking for there is a quantitative determination of the errors in the experiment. So you're going to do 2 types of analyses here. You're going to do a quantitative error analysis. We call that intrinsic error. And in that intrinsic error, you're going to calculate how much error would we expect based upon the instruments that we use, the purity of the substances that we use, that kind of thing. That's the first part. And the second part is comparing that error that we associated with the instrumentation, with the measurement, with the purity of the substances, and comparing it to what we saw in our own experiment. So kind of comparing the theory to the experimental and rationalizing the difference between the two. So, intrinsic error kind of is an overestimate in a lot of ways. We will end up getting a higher % error there than maybe we should, based upon, the measurement and the purity. But it kind of gives us a good idea of where to start. But if our error is greater than that, so let's say that we calculate the intrinsic error for the instrumentation and the measurement to be 1.7%. And we do our % error and it's 3%. Okay, how do we account for that difference? So yes, part of that 3% error that we have is us, dealing with measurement and purity issues. But the other part has to be something controllable, something that we could have possibly done differently that maybe would have improved the error and brought down the % error a little bit. So what we need to do is we need to go back to our data, back to our analysis and say, okay, where is the discrepancy? So most commonly, the biggest discrepancy we can have is based on the mass of the sulfur. So if we're getting an empirical formula of copper 1 sulfide, Cu2S, that would mean that we are expecting 2 coppers for every 1 sulfur. But let's say that in our experiment, it wasn't 2 to 1, it was maybe 1.8 to 1. Okay, so what that means is that we had a little bit more sulfur in the final mixture than what we should have. So how might we have made that different? How might we change what we were doing to make it so that that wasn't so apparent, so wrong? Well, we go back to the procedure and say, well, the sulfur is supposed to burn out. What if it didn't all burn out? What if we didn't burn off all of the excess sulfur, and some of that excess sulfur stayed in the crucible and made the mass of sulfur bigger than it should be? Perfectly reasonable explanation. But we'd have to consider that, and that we'd have to wrap that into the error analysis that we're doing. And so that's what this part is really all about, is in the error analysis, we do the calculation, we compare it to what our % error was, and we start to look for tangible kinds of reasons for why the error is different. The thing we want to avoid is we want to avoid blanket terms in this error analysis. What I mean by blanket term is, oh, it was a calculation error. Okay, well, if it's a calculation error, you should have caught it. That's not something that you could change in the procedure. That's just you being careless. That's not a good enough reason. Or it was human error. I love human error. Human error is one of those things that, oh, it sounds so good. It sounds so scientific, but it means nothing. You can pinpoint error more precisely than just saying, oh, it was something I did. I just don't know what. So in that section, really go back into your numbers, go back into the procedure, and see if there are any places where there could have been improvements made. That's what we're looking for. And then in the conclusion section, wrap it all up. Summarize, this is what we were expecting, this is what we saw, this is what it means, this is how good we did it with our percent error. And that's the experiment. That is the formal report. Now, it says here you're going to have an opportunity to write a rough draft. And that is the case. Your instructor will give you a deadline for that rough draft. It's usually about a week from the experiment itself, but make sure that you check with them and that you know when it is exactly. Turning in the rough draft is worth 10 points. If you want to get the 10 points, you have to at least submit the first 7 sections, which is through the data table. Again, depending upon your professor, you might actually see that you've done the calculations and you've had them verified. You should be able to do the first 8 sections. And depending upon how much time you had to work on it in lab, you might be able to submit the whole thing. What I would encourage you, if you can submit the whole thing, try to submit the whole thing. Your instructor can give you more feedback the more you submit. The less you submit, the less feedback they can give you. The less likely it is that you're going to be able to make big improvements from the rough draft to the final draft. So that's all for this particular video on writing your formal lab report. So once again, stay tuned, and we'll produce more videos like this as other of these projects come about. But again, look for the quantitative error analysis video as well if you're confused on how to do that calculation and that material. But I will see you in lab. Have a good day.